So the data types we've defined so far have worked for a fixed set of types. Another useful feature of data types is that they can be parameterized by what types they're allowed to have inside them. So here's a simple example. This data type here, data pair, is parameterized by two types A and B. So these are standing in for unknown types. And then it has one constructor called mcpair, which has two parameters of type A and B. So this means that values of type pair AB are pairs of values of A's and B's. So you can see how this works if we type in the REPL. So we can make a pair of a string and a number, and that gives us a pair of a string and number. We can ask what the type is with :T, and it's going to tell us, it's slightly more complicated than it needs to be, but it's going to tell us that this is a pair of a list of characters, because strings are lists of characters in Haskell, and something at some type B, which is a number. Or we can say mcpair true A, so that gives us a pair of a boolean and a character, and then if we ask what the type of this is, then it's a pair of a boolean and a character. So this means that instead of using the direction with a distance type with just a pair of fixed things, we can write functions which work on pairs, which work for any type. And we can reuse this type in several different ways to just represent things which are naturally pairs. So here's direction with a distance 3 is just equal to a pair of a direction and an integer. And here, this is a new way of defining types, is using type. So this is just giving a name to an existing type. Same way that value definitions give names to existing values. So this is saying that direction with a distance 3 is just an abbreviation for pair of direction and integer. Since pairs are defined for any pair of type A and B, we can now write functions which work for any type. So rather than writing the getDistance and getDirection functions that we wrote in the last video, we can write getFirst and getSecond, which work for any pair. So getFirst takes a pair of an A and a B and just returns the A part. How do we write that? Well, we write it by pattern matching again. So it's mcpair A, B, and it's going to return the A. So a careful thing to note here is this A here in the type is standing in for a type, and this A here is a variable standing in for a value of type A. And then getSecond is defined how you might think. And then we can load these in and use them. So if we do getFirst of mcpair true 1, then we'll get back true. If we do getSecond, then we'll get back 1. And this works for any type. So we can do mcpair up 100, and it'll get us back 100. So we don't have to write the getDistance function, we can just use getSecond. Another interesting function we couldn't write before is swap. So this takes a pair of an A and a B and gives us back a pair of a B and an A. So how do we write this? We write mcpair AB, so this is the input, so the first part of the pair will be bound to A, the second part of the pair will be bound to B, and then we construct the output with mcpair BA. And loading this in, we can give it a go, so we can take this pair, call swap on it, and it will give us 100 up. We can, and to show this works for any types, give it a string, pair of strings even, hello world, and it gives us back world hello. And here's an even more complex type. So this is the maybe type, which is extremely useful. So this is in fact built in, but if you look at this file in your editor, you'll see that at the top I've hidden that definition to give it to you again. But this is a type which is very useful for writing programs which cannot return a value in some cases. So what's going on here? So again, we've got a data type, maybe. Name is maybe, and it takes one type parameter. And then it's got two constructors. One is nothing, so this is when we use to represent there's no value, and just. And now the just takes a parameter A. So what do values of this type look like? Well, either we say nothing, so we get just returns nothing. We can ask what the type of nothing is, just a maybe A for any A, because there's no A to be filled in here. Or we can say it's just 100, for instance, or just true. So this means it's got a value, and it's just this thing. So it's a bit abstract, but let's see how to use it. So let's say we want to write a function that, given a pair of a direction and an integer, returns the vertical distance. So this means that if it's up or down, it can return a number. And there's a question about what to do if it's left or right. So let's see how we write this. So we write it by pattern matching. So we can say mux pair, and then, well, if it's up and we have a distance, then we can return a distance. We have vertical distance, mux pair down, we have a distance, so we can return a distance. Vertical distance, mux pair left distance, but this isn't a vertical distance anymore, so what do we return here? And similarly for this one, what do we do here? So the answer here is, well, there's one thing we could do, which is return 0, but is that really saying it's the vertical distance? So another thing to do is to say, explicitly flag that we don't know what to return here. So we can say, getting the vertical distance from a pair of direction and integer gives us a maybe integer. So as maybe it gives us an integer, or maybe it doesn't. And now we have to flag which cases do give us a value and which cases don't. So we say in the cases where no value is given, we say just say nothing. And in the cases where a value is given, we say just and then that direction. So now let's try this. So to get the vertical distance of up and 300, well, that's just 300. But if we give it left 300, then it gives us nothing. So this is, rather than returning a dummy value like 0 or -1 or something, we explicitly say that we're not going to return anything. And this is very useful sometimes because Haskell has no concept of a null value like you might see in Java. So if we say we're going to return an integer, then either the program doesn't terminate because it gets stuck in an infinite loop, which we'll see soon, or it returns an integer, and it cannot return null. So if we want to explicitly omit the possibility of null, we have to say maybe integer. So in summary, data types can be defined with type parameters, so they can work with multiple types. And we saw this with the pair data type, which could take two type parameters a and b and work for any a and b. And then functions that work on these data types work for all possible types. Type parameterized data types are a useful way to define common patterns of data types. So we saw that with pair, which is a way of defining its direction with a distance without having to do a lot of typing, and the maybe data type, which you'll be seeing quite a few times in this course.